Sure, I think you can accomplish it just fine. I felt like dividing by 5 first was the better way to go today, just based on how the numbers are. So I'm wondering if anybody has a question or a concern or anything I can do to help. The goal here is just to help you get a little bit better than you were 10 minutes ago, if possible. So I give you time to think. Question, yeah.
Why did you multiply by 3 over 2 for number 1 instead of dividing?
Divide by what?
By 3 over 2.
I would never, yeah, so let's look at that real quick. So if I'll do this in a little different color. So if I just took this over here, I've got 2/3 x equals 3. If I wanted to get the x by itself, I could divide. What would I divide by?
3.
No. Let me back up a little bit. What number, like the x is clearly, like if we draw a little fence here, the x is clearly not all by itself.
Yeah.
What's with it?
2 over 3.
2/3.
Yeah.
How is the 2/3 attached to the x?
Multiplication.
How do you want to do multiplication?
Division.
So we should divide by
2 over 3.
2/3. So check this out. If I divide by 2/3, if you divide something by a fraction, you remember the rule copy dot flop?
Yeah.
So I would go copy dot, and what's the flop of 2 or the flip of 2/3? There's your 3 over 2, right? And on the other side, there's my copy, there's my dot, and what's my flippity flop?
3 over 2.
So now when you look at what I have here, what I have here, they're the same.
Yeah.
So I just copy dot flopped it automatically.
Okay.
Yeah.
Okay.
So, and that's a way you can get rid of any fraction, is just to multiply by its reciprocal. That'll
Okay.
cancel out to be a 1. It'll divide out to be 1.
Okay. Thank you.
You are welcome. What else can I do to help? It's a really great clarifying question. Glad you asked. Go on. Yeah, Chase.
For number 3, why is it not a relation?
It is a relation, but
Or
it's
why is it
not a function. So I'll show you maybe a different way of looking at this. Show you a little graphic here. On the left is going to be my domain, and on the right is going to be my range. So if I was going to list out my domain and range, would you be okay with this? If I said my domain is -3, 5, and 2. So your domain is your x's, and when you have points, like we have up here, like in the little parentheses, it's always x, comma, y. So the first number is x. So I've got my first x is -3, so I put that there. It's the first member of my domain. My next x was 5. That's why I have this in there as part of my domain. And then I got a -3 again. I don't need to put it twice. It's already in there. And then I've got a 2. So that would be the final member of my domain. Does that make sense?
Yeah.
Okay. Now the range is the y's. So the range is 6. How do I want to do this? I'll go 6, 7, 5, and 1. And those are just my y values, 6, 7, 5, and 1. And then what I'm going to do is I'm going to try to draw like a mapping, right? So I would say, doesn't the -3 have an output of 6? Right? The output for 6 is 3. And then the output for 5 is 7. But then this is where it gets a little bit messed up, because it says the output for -3. Wait a minute, I thought the output for -3 was 6. But now right here it's telling me the output was 5. And so this -3 maps to the 5 as well. And of course the 2 maps to the 1. But the fact that the 3 has 2 different outputs violates the definition of a function. A function is any relationship or any relation in which every single input has exactly one output. And in this case, the -3 has two outputs, making it not a function. Let me show you graphically as well. You guys remember the vertical line test? So if I were to plot these on a graph, here's what it would look like. -3, 6 would be right about there. 5, 7 would be up there somewhere. -3, 5, -3, 5 would be about here. And 2, 1 would be, I don't know, like right about there. So do you see how a vertical line would hit both of those points at the same time? So the vertical line test would tell us that it hit 2 points on the graph at the same time, therefore not a function. You can look at it with those ordered pairs. You can look at it as a little graphic like I did with the blue rectangles, or you can look at it on a graph with the vertical line test. In every case, a function has to have all the inputs just have one output only. And this one has the input of -3 with two outputs, making it not a function. Go ahead.
For number 2, well, I got the same answer, but would it be okay to say -1x instead of just -x?
Totally.
Okay, just making sure.
Yeah, Sebastian, this might be worth you all hearing. He said, would it be okay if we had -1x plus 2? And somebody could argue in some ways that's better because you can see your slope. Like if we're going to, if we actually were going to graph this, you could see the slope very easily that way. So totally fine. What else can I do? We don't often get to talk. At least I don't feel like we get to talk that often. Now's a chance. Okay, so today's Wednesday, tomorrow is Thursday. We're going to practice this one more time. And then on Friday, we'll do a quiz, see if you're getting it. Okay? On this DMR stuff. Let me just do one more reminder. Please, I'll write it up here too. Please do your initials project. If you haven't already turned it in, please, that's supposed to be a C. There we go. Please turn that in. Take a picture of it. Submit it to Schoology or share it with me via Google Docs. And that way I can look at all your beautiful work and give you a good grade. Or a grade in some cases, yes.
I was just going to ask
If it's a personal thing, let's just find another time. Yeah, lunch would be good. Okay. I'm set if you are. And you're all telling me that you're set. Okay, cool. Why don't you guys flip over to the next page? I'll get there too. And I have a little story to tell you. And my story is going to revolve, or my stories, I guess, they're going to have a point for sure. There's going to be a reason for me telling you these, but listen, I need you to kind of key in and think, why on earth is he telling us this silly story? Okay? The word that's going to be the focus of my silly stories is that word right there. How many of you have ever been to a restaurant, like a sit-down restaurant in which you can order a meal and they bring it to you? You all done this before? I don't do this very often, but I've done this. You go to a restaurant, you look at the menu, and you think, oh, I feel like, now listen, please, listen. I feel like such and such tonight. I'll tell you what, I feel like getting a steak tonight. Doesn't that sound good? Yes, we should totally get a steak. So you go to this sit-down restaurant, you get the menu, and you're like, okay, steaks, there's a steak. Oh, that's the steak I want. And you look at it, and it says, such and such a steak, however many ounces, cooked the way you want it, And then oftentimes somewhere on the menu it'll tell you some sides, right? It'll say, all the meals in this little section come with baked potato and a salad or French fries and a vegetable dish or something, right? You know what I'm talking about? Well, how many of you have ever gone to some restaurant, got some meal like that, and you look at it like, boy, the steak sure sounds good. But man, one of those sides, like for me, it's like coleslaw. Like when they put coleslaw, this is just my own personal taste. They put coleslaw on the plate. I'm like, you might as well not even put it on there because I'm not going to eat it, right?
Same, yeah.
And so,
Unless it's on like a barbecue sandwich.
even still, I mean, I get it. Some people like it. Even still, I'm just not a fan. I'm sorry, I just shattered your world, but yeah.
That's okay.
In those situations, though, wouldn't you look at it like for me, be the sauerkraut? I would say, oh, I don't want sauerkraut, but aren't I sort of paying for the sauerkraut because I'm buying the whole meal? So might I look at the server and say, hey, I'd like to get this steak meal or whatever meal this is, but instead of sauerkraut, could I get something else?
Mac and cheese.
Like mac and cheese, there we go. So I might talk to the server and say, hey, I would really like this particular meal, but could I substitute mac and cheese for the sauerkraut? Or could I substitute a salad for the sauerkraut or some other vegetables for the sauerkraut or something like that, right? And what might the server say?
Sure.
Yeah, and I'd say in most cases they're going to say, for sure, yeah, a little bit of mac and cheese, a little cup of mac and cheese, sauerkraut, we can trade that out, no problem. No extra cost, hopefully, right? And that would be a fair substitution, right? Because a little bowl of macaroni and cheese and a bowl of sauerkraut probably pretty much costs the same, doesn't it? So that would be a fair substitution. Have you ever tried this? Gone to a restaurant, same scenario, you're getting maybe some barbecue, like Bray was saying, and they got sauerkraut. You should try this if you want to be silly, or they might not appreciate it, so maybe you shouldn't try this. But you look at the server and say, you know what, I want to get the barbecue, whatever, barbecue chicken or something, but I'm not a fan of sauerkraut. So instead of a sauerkraut, could you pull the sauerkraut from the meal and substitute in 17 large pizzas, please? So take the sauerkraut out of my meal,
But we're at a barbecue.
and in place of it, I need you to find me 17 large pizzas. Or maybe if you're at a barbecue place, maybe you could say 17 chicken fried steaks. What might the server say if you said something like that?
No.
Why would they say no?
Because
so many.
there's
So I feel like 17 large pizzas, Anya. It's not equal to, it's not,
value.
the value is totally different. A little bowl of sauerkraut probably cost them 50 cents, right? 17 large pizzas, that's hundreds of dollars, isn't it? There's no way that they're going to just substitute that out because, now listen, they're not equal value. So true substitution demands that the thing that's going in and replacing the other thing, they have to have equivalent value, don't they?
Yep.
One more scenario. Let's say that I used to do this, so I'll just go with this. Let's say that I'm a volleyball coach. I used to be, not right now. Let's say I'm a volleyball coach and I got my volleyball team. How many players are on a volleyball team on the court at the same time? 6. There's 6 of them. So let's say that this is my volleyball team. These 4 folks, 5, 6. This is my volleyball team. Now pay attention, please. There's something to be gained from this. Hopefully it'll stick in your mind. This is my volleyball team. These 6 people over here. Somehow Chase got on the team. He's our all-star outside hitter or something. So we got our 6 players on the volleyball team. And let's say I'm watching a game. We're doing okay. But then, somebody starts to make a few uncharacteristic mistakes. They're not paying attention, or they don't get off the net when they should, or they're not communicating very well. So for a couple of points, couple of rallies, I can tell someone's off their game a little bit. As a coach, what might I do? I might substitute, right? And eventually, if they continue to have the problems, they might get benched, and we need to work on something to help them get better. You said it, right? You said benched, yeah. But at the very least, aren't I going to substitute? So let's pretend that indeed, it was Chase, even though he's our all-star hitter, he's having a hard time. He's not doing very well, and so I'm like, man, I call timeout or something. I talk to Chase. He's not doing well. Like, I need to sub Chase out of the game. He's struggling. So I substitute him out of the game, and in the game I put Sebastian. So Sebastian, I need you to go take Chase's spot out there. We're going to play some volleyball. Like, let's get out there. You can do it, Sebastian. And now listen. These stories can be very helpful, but they can also be distracting. Stick with the point. Remember, I substituted Sebastian in for Chase, right? So now Sebastian's out on the court. So the other team has the ball. They serve it. The other team gets ready to serve the ball. As soon as the ref blows the whistle, Sebastian runs under the net and tackles someone on the other player, gets on top of him, and it's like, yes, I just pinned him. Yeah. He gets super excited. Like, what are we going to do? I don't even know if the referees would know what to do with that, right? They'd be like, oh, what are you doing? Right? So the problem is, of course, Sebastian, he's about the same height as Chase, right? On the surface, it appeared that they would be an equivalent substitution. They even have the same color hair, basically, right? You would figure he would know what to do, but instead of going in and playing volleyball like Chase was, he goes in and starts wrestling the other team. Well, I think we probably have to do that for sure. Here's the point. Now, listen, here's the point. was kind of like the pizzas for the sauerkraut. This is not an equivalent substitution, is it?
No.
If I'm going to substitute somebody into the game and it's a volleyball match, what does the person who substituted in need to do?
Have the same skills.
They need to play volleyball and have the same kind of skills, right? They need to go in and be an equivalent substitution. They can't go in and just do whatever they want and catch the ball and go run out of the gym with it and spike it and say touchdown, right? Now they're playing football. It's supposed to be volleyball, right? So that would be a bad substitution because the two people were not equivalent in ability or apparently brain power, right? We got a serious problem. Sorry, Sebastian. We know you wouldn't do that, but you get the idea, right? Okay. Here's the big takeaway. I'm hoping that my silly pizza story and my silly volleyball story will help you remember this. In order to substitute one thing for the other, the two things that you swap have to be equal. They may or may not look the same, but they need to have equivalent value. Just like the macaroni and the sauerkraut had equivalent value. Or if I did put Sebastian in, he goes in there and he starts passing and setting and hitting, that would be equivalent value. We need that kind of a relationship in order for this to work. Okay? So, I want to review a little bit with you, and then we're going to talk about how substitution works. Let's see how well you remember this. A system of equations is...
A linear.
We're doing linear equations, right? But a system of linear equations...
Interception point.
You're one step ahead of me.
Why?
You're one step ahead of me. It's what?
More than
It's,
one linear
it's
equation.
two equations. It's more than one equation, right? So what is a system? You say it?
More than one.
More than one of them, right? There's two lines hanging out there, right? For us, we'll stick with two. Please listen.
Sorry.
So a system is more than one for us. That just means two linear equations. And then on a graph, what does the solution look like?
Interception point?
Intersection point. Yeah, it's where the two lines intersect. Or what's another way to say intersect? It's where they cross. It's where the two lines cross. So I'm going to ask you this again, and I'm going to need some response from all of you because I need to at least feel like you know what you're doing. I might be right, I might be wrong, but I at least need to feel that way. So see if you can answer, all of you together. Here we go. What is a system of equations?
Equation graph together.
More than one equation, typically graphed together. That's right. Okay, so then if you looked at the graph of these two lines graphed together, what would be the solution for our system?
Interception.
Noah, what's the solution to a system?
The intersection.
Good. I just noticed you spacing out. I wanted to make sure you knew it. Okay? Now, there are going to be some times, I think you can imagine this, where the intersection point on a graph is going to be really hard to find, especially if it's like a fraction or a decimal or maybe a really large number. And so there are going to be a couple of other techniques that we use to help us solve a system. Graphing, like we did yesterday, that's a good way. But if the numbers are really big or really small or fractions or decimals, then this method here, substitution, is going to be a good way to do it. So I thought I would show you one of these, and we can kind of work on this one together. And then I'll turn you loose on one and maybe two of them. We'll just kind of see how it all goes. I'm not going to rush through this. You're going to ask me questions if I do something confusing, right? Good? Okay. So take a look at number one. Number one says, solve this system using substitution. Now remember the pizzas. Remember the volleyball. You should all have your pencils ready to go right now. Remember the pencils and the pizza and the volleyball. In order to substitute one thing in for the other, those two things have to be equal. So I see, in my system, I see two equal signs. And so this is good news because I'm trying to look for two equal expressions where I could substitute one in for the other. And I noticed in the first equation that the y happens to be all by itself on that left side of the equal sign. So here's what that means. That means that the y has the exact same value as 5x minus 2. Isn't that what that little symbol means with the equal sign, right? That means that the y and the 5x minus 2 have the same value. So in other words, if I said, hey, I would like to buy your bicycle from you, I'll give you y dollars. it would be the same as if I said I want to give you 5x minus $2. They have the same value. So I would say that the y is like sauerkraut, and the 5x minus 2 is like macaroni and cheese. They don't look anything alike. But because of the equal sign, they have the same value. Does this make sense? So sometimes we look at the equal sign as just and my next thought was, the equal sign is very powerful. It tells you that whatever's on the left and whatever's on the right, they have the same value. Whether they look like they have the same value or not, they do because of the equal sign. So here's what I can do. In the other equation, the one that does not have the blue box around it, you should be writing with me here in just a second. The equation that doesn't have the blue box, what I can do then is I can replace the y with what y equals. So this is me substituting. So here's my volleyball match. I've got 6x plus, oh my gosh, y is not playing very well. I got to get y out of the game. Y is really hurting the team right now. So y is out of the game. Notice how I've taken y completely out of the game. Do you see it?
Yep.
What is the only thing that I could replace the y with that will be equivalent?
1.
No.
0.
5x minus 2. Right? Because the only thing that is equivalent to y is 5x minus 2.
Oh.
So I have to replace the y with 5x minus 2.
You got 6x plus 5x minus 2 equals 9.
Correct. So I have taken the y out of the game, I've taken y off the menu, and I've replaced it with the only thing that it is equivalent to, which happens to be 5x minus 2. So do you all see how somebody could call this step the substitution step? That's the place where I took something out and I replaced it with something that's equal to it, something equivalent value, with equivalent value. Does that make sense? Okay, so once we get to this substitution step, the rest of this should feel a lot like the equations we've solved in the past, where we would simplify. Does anybody see any simplifying I could do on the left side?
Yep. 5x, 6x.
Yeah, those are like terms. So it'd be 11x minus 2 equals 9. So I would then add 2 to both sides. Yep, so plus 2, 11x equals 11. And what's my final step?
1. Well, divide by
That's the final answer for sure. But yeah, dividing by 11 will give me x equals 1. Wow, kind of cool, right? And this feels like we are totally done, doesn't it?
Who said 1 in the beginning?
I don't know.
Someone said the answer was 1.
Okay. Now please, hey guys, listen up. So Mason just brought up a really good point. He said the answer is 1, and I'm going to tell you right now, the solution to this system is not 1. Let's go back. We said this at the start. If I were to graph a system of equations, the solution is where?
They intersect.
Where the lines intersect. Isn't that a point on the graph?
Yeah.
And a point on the graph requires that we have what?
But it says solve using
What do we have to have? We have to have an x and a y. All I have right now is an x. That's all I've got. So can anybody think of any way I could conceivably get a y to go with that x?
Plug x in.
Plug x into what?
Y equals 5x minus 2.
Either equation will work, and that would be a fine one to use. So what I'm going to do is I'm going to come over here and I'm going to say plug in. So after I substitute and get an answer, I'm going to plug back in, and I'm going to say y equals 5 times 1 minus 2. I'm going to plug that x back in. I now know that the x is 1. I just got to figure out what the y is supposed to be. So once I plug in, obviously 5 times 1 is 5, and 5 minus 2 is 3. So an x is 1, y is 3. So my final solution would be 1, 3, and that is my answer. That's my solution to the system. Chase. Of course you can. Yep. Okay, so what do y'all think? So far, so good? Okay. Let's see here. I just want to flip over real quick. Will you guys please, you know what? No, let's do number 2. I want to do number 2 unless you have a question. I'm going to help you start number 2, and then I'll let you try to run with it, okay? So here we go. Number 2 looks like this. Hey, by the way, all of this has been recorded. So if you're doing your homework tomorrow night or the next night or something, and you think, oh man, that substitution thing in class, it seemed to work so well, and now I've forgotten, you know what you can do? Go on Schoology, push play, and be like, oh, what? I'm recording it right now on my iPad.
Can it hear me?
Yes.
You might be talking a little too quiet. It might be able to hear you.
Can you hear me?
Yeah, for sure. Minute 25:27, Bray talked. And like minute 25:22, Mason talked. Yeah. Right, see?
It's like
Timer
me. It's like
going.
me in the future.
That's right. Okay. So take a look, please, at number 2. Do you see how number 2 is a little different than number 1?
Because it doesn't.
In that, what do you see?
I don't know how to.
The y is by itself.
There's no y, or for that matter, there's no x by itself either, right? And so there are going to be times when we're doing substitution or a system like this, and we have to create the substitution ourselves. So if I wanted to get either the x or the y by itself, I could actually get any of those x's or any of those y's by itself. But in my opinion, there's only one that's easiest. What would be the easiest variable to solve for?
1.
Well, 1's not a variable.
0.
The 0's not a variable either. Which y? The one on the top equation or the bottom? Why would that be easiest? It's already got a coefficient of 1. Maybe that's what you were talking about. So if I wanted to take this, the bottom equation, if I wanted to take this and get the y by itself, what would I need to do? Subtract 2x. So this would give me y equals 3 minus 2x. Okay? So now we're in a very similar place to where we were just a minute ago. So what I would encourage you to do, I want you to try this. In the other equation, see if you can replace the y, or substitute the y out, and put a 3 minus 2x in its place, okay? There's some additional factors in here that make this a little bit tougher, but it's very similar to what we just did. Yes, ma'am? Yeah, put it in place of y, yep. That's a good substitution step for sure. So assuming that you did all the subsequent steps, I would say this would make sense. Make sure, though, that your answer is always a point. So you should have an x and a y. For sure. And you can use either equation to get that second coordinate. But that looks like a good strategy so far, for sure. Let's see if we can get a substitution.
Understand it. Like, I understand this one. I don't understand this one.
So we got this from this, right? So then what we're going to do is in the other equation, we are going to replace the y with that.
Oh.
So just like up here, we had this, and we went to the other equation, and we replaced the y with that.
Oh. Okay, so it would be like.
And then you just.
Oh, wait.
No y equals. We would just start off with 3x plus 4, and we want to get the y out of there.
So, like that.
That equals 4.
Yeah, equals. Don't lose your equal sign.
That's a negative 4.
There you go.
Okay.
Get busy solving, and you'll be there.
Okay.
That I would call that your substitution step.
Okay. So you okay.
Nice. Okay. So far, so good. Not so nice. No. Yes. Where are we at? Trevor, we're doing okay? Do you have any questions for me?
I have a question.
Sir.
So I got it. But what is it equal to?
Oh, okay. So this will be an easy fix. Okay. So you've got your 3x. You replace your y with 3 minus 2x.
That's times.
Equals
Equals negative 8.
negative 8. So equals negative 8 equals negative 8
Oh,
equals
and then I
negative
can
8.
add this.
And then you get down to just the regular old
Okay.
solving like you always do, and yeah.
This is correct.
I don't have the answer memorized. You can always check real quick. So you know what you could do is you could plug in right here. So the 4, this would give you 8 plus negative 5. That's 3 equals 3. That makes sense.
Yeah.
4 up here, that would be 12 plus negative 20 12 plus negative 20 is negative 8, and that equals negative 8.
Oh.
I would say we just proved it.
Okay.
So you should be able to always plug back in. We
Okay.
did one of those yesterday.
Okay.
You could always do that if you wanted to check your answer.
Okay.
Okay, I got it. Thank you.
Awesome. Yeah, you bet. Hey, at this point, I want to show you the substitution step. So please, if you could, take your attention towards the screen. I want to make sure that either you're good with this or I inspire you to ask a question. Please watch. Hey, this is where you get lost. I need maybe like 1 minute to explain, hopefully in a good way, what to do here. I'm going to take the other equation, the one that's in the blue box, and I'm going to take the y out of the game because the y is messing up our team. Yep. So it's going to be 3x plus 4. The y is out of there, equals negative 8. What is the only player that I could substitute in for the y? 3 minus 2x because they're equivalent. I've got to use parentheses here because of the 4. So it'd be parentheses 3 minus 2x goes in for the y value. I would call this my substitution step because I have replaced the y. I've substituted the y out and replaced it with 3 minus 2x. Okay? Do you want me to keep going or do you want to? Looks like a lot of you are done. Okay, so I'll keep going. What property do you see up there? Distribution, yeah. So the 4 gets distributed. This would be 3x plus 12 minus 8x equals negative 8. On the left side, do you see the like terms?
8 and 3, which would be negative 5x.
Yes, negative 5x plus 12 equals negative 8. What's my next step?
Negative 12.
Yeah, we'll go minus 12 from both sides.
That's negative 20. Negative 5x equals negative.
And I finally divide, right, by negative 5?
Yes, to get x equals 4.
And I get x is equal to 4. And this is that danger point where you would feel like, yes, I finished it, I'm done, I'm good. But remember that a solution, guys, a solution to a system is, it's a point. It's an x and a y. It's the point where the two lines intersect. So I've got to find the y. I call that the plug in, or the plug back in. Does it matter which equation I plug back into?
No.
It really doesn't. I think I would probably use the one that I'm putting a lovely green box around. I think I'd go with that. So I'd get y equals 3 minus 2 times 4. This would be y equals 3 minus 8. And 3 minus 8 is negative 5. So my final answer would be 4, comma, negative 5. I've got time for one more example, but I don't want to do it until I feel like you have a good chance of being successful. So do you have any questions? All right. So I think number 3 would be a nice one to finish with. Please take a look at number 3. Oh, sorry, it's a new number 1. We're on practice 2. Sorry. I forgot how I numbered this. Yeah, so practice 2, number 1. It's got A's and B's in there. And it's really similar to the one we just did, right? So I'll put it up on the screen for you. You can see it up there too, but it's in your packet. Practice 2, number 1 is right there. B minus 8A equals 2. 5A plus 10B equals 3. Please try this. This will be our little, kind of our little exit ticket.
B by itself or A by itself?
Well, that's a great question. So there's 2 different B's and there's 2 different A's. And of the 4 options, right, because you could solve, I mean, let's just be honest. You could solve for this B, you could solve for that A, you could solve for this A or that B.
It's not showing.
Oh, sorry. There's four options for you. And any one of those options is completely valid, but only one of them is going to be easiest.
That's the bottom one.
I disagree.
Oh, top one.
Because isn't the top is just one B?
Yeah.
So that would just be a 1 step to get to the B by itself, whereas the other ones would be 2 steps at least. So I would go with that.
This is more confusing.
plus 8a, you've got 2 plus 8b all of a sudden. Should be 2 plus 8a. So Chase, your first step needs to be to get the b. I'd say that upper b by itself is going to be the easiest.
How would you put that into this? Because I know how to do this one really easily.
b equals 8a plus 2.
How would you?
So wherever you see a b in the other equation, you would replace that b with 8a plus 2.
I did that. I got 85.
I got 85a equals negative 17.
Terrifying.
That's what I got too. And I was like, I don't know.
It works out nicer than you think.
But look,
You're just afraid of the ugly numbers, right? Which I get.
is that actually
It
right?
works out, like try it. You could use your calculator, I suppose, if you want, but
I don't have one.
it works out pretty nice.
Do I divide?
Look what I have.
That's what I did.
I don't freak out when I see ugly numbers.
Well, I
You
do.
shouldn't either.
I did and I erased everything.
It's okay.
Wait. Then how do you get them in the like thingies?
You get negative 17. How would you even divide this?
Yeah.
You can keep it as
Spam.
Wait, Mr. Anderson?
Hold on. Spam.
I got here.
This should be 2 plus 8a.
Do you do cheer too?
We're just going to change that and that. Yep, that'll change everything from there on out.
Are you good at it?
So Mason, that's a lovely start.
Yeah.
Can you at least do the substitution step? Remember, the substitution step is you take this and you rearrange it. So this was a good move. Now in the other equation,
So 85 plus 20.
wherever you see a b,
No, 85a plus 20.
you replace it with that.
20 plus 85a.
So that's what we've been doing over here. Let me show you. Oh my gosh, Mason.
I didn't know what we were doing.
Can I tell you why? I'm making an assumption about Sophia here. I hope I'm right. So check out the difference in the notes that she is writing. Solid. Not even close. If you were to look at me and say, gee, Mr. Anderson, I don't know why I don't understand this. Right?
Yeah.
You need to actually write down. Like, this is your answer. Remember the email you sent me the other day?
Yeah.
This is the answer to your email.
Okay.
Seriously. I mean, I'm glad I could spell it out plainly for you. This will not get it done. You will be forever confused if you put this much effort into it. That's just the facts. Okay? You would suck at hockey if you never practiced it, right?
Yeah.
You're not practicing math. That's why you don't understand. You with me?
Yeah.
So, don't ask me a question you don't want to hear the answer to. Or maybe you did want to hear it. I don't know. Sophia, what's your question?
How do you divide that?
Yeah, people are freaking out about that a little bit. You did nothing wrong. I'll show you. I'll put it on screen. Hey, let me show you the first part here real quick. Some of you guys are unnecessarily freaking out over some numbers. Oh my gosh. Nothing?
I just forgot how to start it, and then I looked back here, but it's not the same. And I didn't.
Okay, watch the screen. So my answer that you're about to see is not complete yet. It's not wrong, it's just not complete. Okay? So check it out. So what I did, step one, you have to get one of the variables all by itself. So I took that top equation and I found that getting the b by itself was super easy. All I had to do was just add the 8a over to the other side. So step one is to get one of the variables by itself, because you're going to substitute, right? The pizzas and the sauerkraut, or the macaroni and the sauerkraut, you got to set up a good substitution so that you actually can trade one for the other. Then, once you have that, in the other equation, notice, please, how I replace the b with the only thing that the b is equal to. So I took the b out of the game, and I replaced it with 8a plus 2. And I'm allowed to do that because I know that b and 8a plus 2 have the same value. You with me? And then what follows is some simplifying and solving like what we've done in the past. And a ton of you got to this step right here and just thought, oh my word, I don't know how to deal with that. It's a fractional answer. It actually does reduce down to negative 1/5. But it does actually reduce down pretty nicely. Okay? Question? No? Okay. So guys, listen up. Here, I want you to hear my heart on this. You gotta be honest, like over the course of a class period, how many times do I say, how are you doing? Do you have a question?
A lot.
And how often is the response
Not a lot.
that? Yet, now here's where there's a disconnect, right? So listen, here's where there's a disconnect. As I started touring and walking around and peeking over shoulders and trying to answer questions, I found a ton of completely blank efforts on this question. Now, certainly a lot of folks had something good, or they started, or they were on their way or something, but there was a decent number of you that had nothing or almost nothing written down. Yet when I offer any questions, nope, I'm good. Are you serious? We gotta open up. We gotta open up. Let me finish this one for you. I hope you hear me say that in love. Like, I have one goal, and that's to help you learn. That's it. It's hard to help you learn when you won't open up at all. So you got to open up. All right, here we go. After I found that, I've got to plug in. And I would say of the two things I could plug in I probably would plug into this one. I'm going to plug in, check it out, 5a. Well, a is negative 1/5 plus 10b equals 3. I'm just going to plug back in. What's 5 times negative 1/5? It's not 1, it's negative 1, yeah. So negative 1 plus 10b equals 3. What would I do to get the b by itself? I'd add 1. I'd add 1 and then divide. Yep, so it'd be 10b equals 4. Here's that division that Sasha was just talking about. Divide by 10. B is equal to 4/10, which is the same thing as 2/5. How do you think I should order my numbers? Should I put A comma B or B comma A? Should always go in alphabetical order. So A comma B. So my answer would be negative 1/5, comma 2/5. A little nicer than we maybe thought to begin with. Okay, so there's substitution. Tomorrow, we'll talk about a different method called elimination. Anyways, hope you have a great day. See you tomorrow. Yes, sir.